Let's get introduced to the STL vector. It's a data type defined as the standard template library. It can hold a value of any type, or it can hold values of any type. So it's similar to an array, but a little bit different. Notice the syntax we have on line 18. We have a vector int scores. Now, unlike arrays previously, which were fixed size, these are not fixed size. They automatically add space as needed, but like arrays, we are going to be using the brackets, these things, to determine what index we are going to be looking at to access elements. So we still have indexes and elements, just no fixed size. Declaring vectors look like the following here. First, you're going to need to include vectors in your preprocessor directives. This can hold many different int elements. Now, commenting all of this out for now, if I wanted to initialize this to something, you can use parentheses here. And let's say we do 30 and 0, and then I use this while loop to print it out. We're going to have 30 zeros. So you can initialize all of the 30 indexes to 0. If you do 1, it's going to be the same as well. We'll go over what this while loop is a little bit more down here. I just copied and pasted it. I don't know why it's continuously running. We can stop that. And if we put this while loop down here, change this to finals, while finals is not empty, we are going to run finals dot back. Don't worry about what all of this is. Again, we're going to go over in a second. I just want to show you what's inside of the vector currently. Now you can see that I moved the while loop down here, and I'm basing it off of the finals vector. And what this one is doing is that you can have a vector inside of a vector. So this previous vector, we still have 30 elements all set to 0. Well, you can set this new vector to be a copy of what the other vector is. So you can see we have 30 elements in here, all are set to 0. The pushback member function adds elements to a full vector, or to a vector that has no defined size, or anywhere in your program. Remember, vectors don't have specific space requirements, so you simply take your vector name and you do dot pushback, and this is going to add 75 to the end. If you want to see the current size of your vector, you just do the vector name dot size, and we can run this and we can see what we get, because we have two cout statements here. So I want to show you what the current size is and then what the first element is. So you can see that the size is 1 because we only have one element, which was 75 here. Now if I did scores dot, and you can see there should be a few different things that come up that you can do. You can see that these are a bunch of different vector methods that you can use. All of this, tons of it in here. And if we do another push back, and we'll add a constant value of 65, and we were to run this again, ooh, it's going to give us an error because I don't have a semicolon. Let's put that in there, and then stop our run, and then rerun it again. You'll see that we're going to have a value or a size 2, and then we're going to have still 75 because I'm only getting the first index. That's pretty much how we would add to a vector, and then how we would see the size of it as well. And then I'm just printing out end. Not sure why I'm doing that, but we can have this cout statement here, or I print final 0, and it should be the same index as our scores. Oh, I know why. It's because this right here, it's not going to tell you that it has an error. See, I just ran it by putting it in. Notice how the end's not there. It kind of breaks the program. And this is because there's nothing in our finals right here. So we make this vector all the way up here, but our scores is only updated right here. So let's take this for now and let's put it right here. So now, since our scores has two values in it, when we have this vector set to our other vector, we should now have those two values in it as well. So when we call finals, you can see that we have the same value, 75, in our index 0. Now what about removing vector elements? Well, you can remove the back ones, or you can remove all. If you want to remove just the back one, the most recent one, you would just do scores.popback. So the vector name .popback. Adding is pushback, removing is popback. If you want to remove all at once, you would just use clear. There's a few other methods, like I said. You would just use the vector name, and depending on your IDE, a lot of different methods should come up. Now let's talk about looping. You can run this while, and then you can print out the whole vector. So scores.empty. Now when you do this, you can only look at the back, right? And so what this means is that you need to print the back and then also remove the back when you're done, so that you can look at the next element after this. Like let's say you have a list of 1, 2, 3, 4, 5, and you want to print out the very back one. You'd print out 5. Well, when you go through the loop again, you want to now print out 4, right? So you have to get rid of 5. And then you would keep going down. That's why it's kind of useful to set vectors equal to each other if you want to store the original values, because here you're just getting rid of them while printing them out. This is arguably a better data type than arrays. If you don't know the size of what you need to store values in, vectors can be a great resource for you. If you do know exactly how many values you want to store, arrays might be better for you. That's going to be it for vectors. We learned how to loop, we learned how to remove, we learned that there's also other methods you can do on top of adding and then declaring. So that's going to be it for our STL vectors with the standard template library. If you have any questions, as always, leave them in the comments below. And if you want more C++ studies, check out that playlist linked below the like button.